All right, we're going to talk about lesson 8.1, which is the start of chapter 8, which deals with vectors. So today we're just going to talk about what is a vector versus a scalar, how do we represent them, how do we add them, and what are they used for primarily. So in terms of from before, we've seen triangles. We've used triangles to solve problems. We're basically going to use some of those same principles. We'll use the law of sines and law of cosines down the road to solve our problems. But we're going to draw two-dimensional vectors, and then we're going to break them into different diagrams and components to solve various problems. All right, so we're going to look at geometric, for this section, geometric representations, and then look at some problems down the road. All right. We have a lot of terminology here. Really the important pieces are looking at just what is a vector. Okay, so trying to think about, we have a vector. We basically have, in a nutshell, a vector is going to be, it's going to have a magnitude and a direction, which sounds potentially difficult, but it's not too bad. Is basically, if I have something that goes in a direction, right, that has a magnitude, something like 20 pounds of force, so 20 pounds of force, and it's in some direction, I'd say, I don't know, 40 degrees, then that becomes a vector. We represent them usually with arrows in 2 dimensions. All right, so we'll go through all that slower in a second, but we have for our values, we have, excuse me, we have an initial point, which is the start. So if we're looking at an initial point, that's where it starts. The terminal point is going to be where it ends. We have a direction. A magnitude is going to be the value that's attached to it. Another word for magnitude, if we're looking at it geometrically, is going to be length. And then we have different ways to talk about how they're represented. So in terms of a bearing versus a standard position. But again, if we keep in mind that what we're talking about is something that has a direction and has a magnitude or size, that's our basic definition of a vector. All right, so what we want to do is talk about basically vectors versus scalar quantities. So a vector, again, has magnitude and direction, whereas a scalar is just a number. So you can scale something up or down. So if I just say 20 miles per hour, that is a scalar value. I don't know which direction I'm going. If I say 20 miles per hour west, that directional piece makes it a vector. So if we look at the examples down here, if I just have a boat traveling 15 miles per hour, I have no idea where it's going. That is going to be a scalar quantity. If I have a hiker walking 25 paces due west, again, what I'm looking for something to be a vector is that it has magnitude. So this is my magnitude. All right. And then this is my direction. So if something has both magnitude and direction, it's going to become a vector. All right. The last one is maybe a little bit counterintuitive. We have a person's weight, which is going to be, let's say they're 150 pounds. And that's their magnitude. Now, we're not specifying explicitly the direction, except we know that we have our weight is our downward pull, right? It's that gravitational pull from the Earth downward. So since there's a downward component, that's the direction. And again, since we have magnitude and direction, this is going to be a vector quantity, right? So again, we were looking at vector versus scalar. A scalar is just a value, like 25. A vector is going to have that scalar part, and it's also going to have a direction attached to it. Okay, so we want to look at whether a hockey puck shot northwest at 60 miles per hour is a vector or a scalar quantity. Again, what we're looking for is, do I have a direction? I do, right? Northwest is a direction. Do I have a magnitude, right, or a size? Yes. So I have a magnitude or size. And since I have both of those, that is going to be a vector quantity. Okay, so we can look at another example. I have a tennis ball served at 110 miles per hour. Again, if I look at it, I'm looking for two things for it to be a vector. I'm looking for magnitude and direction. Well, there's my magnitude. Okay, so I have a magnitude. Now I'm looking for direction. I don't know if the 110 miles an hour is up or left or right or down or whatever. So since I only have a value that's the size, that's going to be a scalar quantity. All right. And then the last one, we have a sprinter running 100 meters north. Again, as we're looking at this, we're looking for magnitude, which is the size there. So there's my magnitude. And then I have a direction, which is north. So if I again have a magnitude and direction, I have a vector and not a scalar value. All right. So you are going to complete this one on your own. So on your homework sheet, you need to determine whether a tow truck pulling a car due east with a force of 100 newtons is a vector quantity or a scalar quantity. Again, you're trying to identify a direction and a magnitude for it to be a vector. All right, so we talked about this a little bit before, but we have a little bit more terminology in terms of how we draw our vector values. So again, as I mentioned earlier, we have an initial point and we have a terminal point, and then we can represent that two different ways. So our standard position is very similar to our standard position for the unit circle, where I have the origin is my initial point, and then somewhere out in space on the coordinate plane I have my terminal point, and I have a direction up from the horizontal x-axis. So up 35 degrees would be that value. If I had another one, so if I had a vector that was, so let's say a vector v, which is 15 pounds at 110 degrees standard position, right? I'm going to have my general sketch of x and y, and then my vector is going to be somewhere over there where the angle that I have is 110 degrees. So there is 110. Okay, and then my magnitude on that would be 15. So that's again for my standard position, and that should hopefully make sense. It's the same way we've done angles before in our unit circle. Unfortunately, that's not the only way that we have vectors in terms of how they're drawn. We have different systems from different historical uses, like sailing, where they've defined vectors differently. All right. So if we're trying to sketch these out, we can use a ruler or a protractor. We can, for us, just kind of sketch it. But what we're looking at again is from the horizontal. So those are my 30 degrees standard position, right? And then I have a distance, which is in this case 10 newtons. And so I have 10 newtons at 30 degrees from horizontal would look like this. So it'd be in that first quadrant if we were in our kind of graphing piece. All right, that's it. If we're looking at this one, so I have a vector z that's 25 meters per second at a bearing south 70 west. This is a little bit different than what we've seen before. So if we're looking at our values, and I have my plane, oops, so I have my kind of map, north, west, east, and south. What I have here is south 70 degrees west. Okay. The first value, the south, means I start here at the south, and then I go 70 degrees to the west. And so south 70 degrees to the west